Okay, guys, welcome to the DevOps Workshop. This event is brought to you by CougarCS. My name is Nykolas Farhangi. I am the Director of Tutoring at CougarCS, and today I'll be co-hosting this event with my friend Vyas.
Hi everyone, my name is Vyas and I'm the Secretary of CougarCS.
Hell yeah. So today we want to talk to you guys about what is DevOps. So for those of you who don't know, which I think is everyone, DevOps is this very hot methodology that has been recently taking the business world by storm. There's a lot of adoption and a lot of companies are shifting towards this line of thought. Today we want to introduce the concept and give you guys a brief history before hopping into the benefits. After that, we'll take a really deep, once you guys have like a nice understanding at a high level what DevOps is, we're going to take a deeper look and break it down into its components and how it works exactly. And then after that, Vyas is going to give you guys this awesome demonstration that he set up. It's basically he made his own like DevOps practice for today's event, and you'll get to see just how powerful this tool is. And he might also treat us to showing what's going on behind the scenes at CougarCS because we actually employ DevOps practices within our organization. And at the end of this event, we'll wrap up with some useful links and resources where you guys can get some more information and yeah, do some further reading if you're interested. Now, before we hop into the event, let us talk about some other things that CougarCS has going on. This Thursday, we have a React workshop, The Next Level. In this event, this is geared for people who have some web development experience already. Basically, if you know how to create your own React app, which is running a few terminal commands, then you should be set for this workshop. In this, we'll be talking about some like intermediate to advanced level concepts. So if you're looking to level up your React skills, come and join us. Next Monday, we have the CougarCS officer elections. Come by, show your support. It's a democratic process, so you'll get to listen to some people's speeches and vote on the candidates who you believe are best. And if you're interested in running for an officer position yourself, the application is open till the 15th, so this Sunday. So definitely go and apply if you're interested in becoming an officer. Next Thursday, we have the workshop conference. This is hosted by one of our officers, Tuba. And then next Friday, we have the regex workshop. This event's going to be hosted by myself and a good friend of mine, Adil, and we'll be showing you guys about this really, really cool tool that you may not have heard of already called regex. It is seriously phenomenal. It's really good at doing what it does, and it can like take some pretty big algorithmic problems and reduce them into some seriously like simplified, one line of code. So really cool tool. If you guys haven't heard of it, definitely come check it out. It's next Friday. Here, we also provided the link to the CougarCS events announcement channel. If you guys want to stay up to date with what's going on at CougarCS, definitely follow that link. I put a QR code there, so you can just scan it with your phone. And if you don't have a chance, or if you want to like reference this sheet later, we will send this PowerPoint out, so you'll be able to get all this information at your leisure later. So with that being said, let's go ahead and hop into the event. So what is DevOps? DevOps isn't any singular tool, software, or programming language. What DevOps is a collection of these processes, culture, and mindset. It basically is an umbrella term which wraps around the cultural philosophies, the different practices, and the mindset, which all come together to shorten the development lifecycle and enhance an organization's ability to deliver applications. So DevOps depends on four core tenets. The first one is encouraging collaboration. So what this means, and this is the first and foremost, the core tenet of DevOps, which is enable communication between everyone that has a hand in an application or a services lifecycle. So I don't just mean the individual teams in a business or the manager and the project stakeholders. I also mean like the client, the end consumer. Everyone who has a touch or is affected by the product should have a voice in the conversation and be able to work together. The next tenet is continuous and proactive improvement. DevOps itself is the idea and methodology of DevOps is itself an improvement of previous methodologies that came before it. You may have heard of some of these like, lean movement and agile. DevOps was built on improving the process of, how do we do business better? And DevOps is constantly looking at how do we do things better, moving forward. To a DevOps engineer, there's no such thing as a perfect product. And I mean this at the application level. The application can always be better. But I also mean like, how does DevOps get better? How do we, innovate in product and software development? The next tenet is automate everything. And I mean everything. Anything that any process that you can remove the human out of the equation and let a robot do it for you, the DevOps wants to encourage that you just let a robot do it. There's no reason that a highly qualified DevOps engineer should be doing work that can be scripted, right? And lastly, the last tenet is to unite teams and expertise. So this is a follow-up to encouraging collaboration. And what this is it really separates from what the classical model of software development. This is what really separates DevOps from the classical model of software development. What DevOps does is, in the classical model, what you generally see are independent teams that are siloed. You'll have a development team that is responsible for producing the application, an operations team which, manages the application. You might have like some quality assurance guys who are specialized at, testing and getting, testing that the code works and making sure that everything looks good. What DevOps wants to do is instead of having these independent teams, which each do have their own set of backlogs and push tasks to one another, unite these teams together and have them work in one cohesive unit. Instead of having a bunch of teams that are specialized in one area, have a single team which is comprised of a security representative, who can take care of the security vulnerabilities of an application and the operation and development. This pillar right here is what makes DevOps, one of the things that makes DevOps so effective is that you bring all this expertise into one room, into one building. So here's a little bit of a brief history of DevOps. So in the 1980s and 90s, this is where DevOps kind of got its roots. There were a bunch of independent practices that took place in this time. During this time, we saw things like the lean movement and tech automation. People were looking for ways to simplify their workflows and reduce the bureaucracy in business. Then in the 2000s, CICD first takes off, and this is continuous integration and delivery. The Agile Manifesto, which was heavily influenced by the lean movement, was published, and the term DevOps was first coined. Then in the 2010s, this is where it gets really interesting. Continuous delivery, which is this idea that packages build, test, and deployment automation all into one pipeline, emerged in parallel in the 2000s, and it provides the key technical basis of DevOps pipelines, which is the main structural feature of DevOps. Next, innovations in server and cloud technology led to ideas such as infrastructure automation. How do we automate everything in our business? Not only the development lifecycle, but how do we automate the business workflows and our infrastructure? Now today, many tech companies around the world, large and small, employ DevOps practices in their workflow, and the idea of DevOps is continuously evolving to include newer tools and ideas which push these core tenets forward. And I mean, this plays on that fourth tenet which I mentioned. Continuous proactive improvement. You're never be satisfied. Always be looking to push the line forward. So let's talk about some of the benefits of DevOps. On the right side, I have listed the benefits and I've broken it into 3 areas. First, we have the technical benefits. The main key technical benefit of DevOps is continuous software delivery. What this means is a developer can push a change through to the source code and within minutes have a product that is a package that is ready to deploy and ready to be consumed by the end user. What DevOps also provides for is much less complexity. Instead of having really complicated workflows where you have engineers who are specialized in the deployment and operation and all these different aspects, DevOps looks to eliminate all this complexity and simplify things with automation and and like basically streamline the process wherever possible. And what this leads to is faster problem resolution. Whereas before, if you have an issue on let's say you deploy a website, if there's an issue, you have to go through the entire process of, updating the code, then, passing it to the operations team where they handle re-uploading it and deploying it. It's an entire process. But with DevOps, the idea of continuous software delivery, you can push a change through and get your problem resolved quickly. Now let's talk about the cultural benefits. Companies that employ DevOps report happy, more productive teams and higher employee engagement. Now this makes sense. Instead of having people do, highly qualified people wasting their time doing things that can be done by a robot, you have, robots taking care of that, and you free up these resources and people to be doing things that they're actually, more interested in doing. The fun part of the job. Actually programming, actually, figuring out ways to push the envelope forward. Things like that. And next, the benefits to the business. All these benefits that happen internally, these absolutely are reflected on the business, which is fast feature delivery. Businesses that employ DevOps can stay extremely competitive because while their competitors might be spending a lot of time in the infrastructure side of things, pushing code through and actually getting deployments, businesses that employ DevOps can very quickly make changes and then roll out features much quicker than non-DevOps enabled businesses. Another big benefit is improved collaboration. Businesses that have their individual teams working so closely together, better ideas come to light, and new solutions come up where originally if you have your independent development team, operation team, QA team, you might not have the same innovation as when all these big brains are working together. And with all the time saved from automating the process and improving collaboration, there's just more time to innovate. Now, on the left, we have some statistics. These were pulled together. From this website, they basically pulled together a bunch of companies that had employed DevOps and asked them for like the before and after. And the numbers we see are pretty startling. We see 200 times more frequent deploys. Companies that employ DevOps are able to roll out features and roll out deployments much faster than companies that don't. 200 times as fast. Following on this, we have 24 times faster recovery times. If there's an issue, if like the website crashes or if there's some bugs that are detected, it's much easier for a team to go through and push the change when they have methods to simplify this process. And then next we have 3 times lower change failure rates. So when we roll out an update, it's 3 times less likely, companies that employ DevOps are 3 times less likely to run into failures that weren't detected before the deployment. So these are all some really great benefits. And as you can see, DevOps is a seriously cool collection of ideas. And now that you guys kind of have an introduction, understand the tenants and its history and benefits, let's go ahead and take a deeper look at how DevOps works exactly. So DevOps, as some of you may have been able to put together already, is an abbreviation of 2 words, development and operations. And these 2 ideas are basically these are the 2 like major components of what makes up a DevOps work cycle. So on the left side of this diagram, on the right side we have this diagram. The blue left half of it is what makes up the development part of the cycle. And this consists of app planning, actual programming and development, building the project, and then testing it. And then on the right side, we have operations. This is the side of it that's responsible for releasing the code, actually deploying it onto the server, deploying it out, rolling it out to the end consumer, and then maintaining the code, scaling it when needed, upscaling and downscaling when needed. And they basically provide support for the application in between these update cycles. What's so cool about DevOps is they put these, traditionally separated roles into one. And it creates this awesome feedback loop where the developers, at the very beginning, they have a list of plans. They have a, backlog of items that they want to roll out. They program these changes. They build it all together. They do some testing. And then once they feel like it's ready, they pass it to the operations team. And then the operations team, handles the release, deployment, operation, monitoring. And then, at this point, they can collect feedback. They can see what needs to be done next. And then it flows right back into the development team where, the development team can then, with a fresh backlog, they can figure out what's next and the cycle can repeat. As you can see, this is a really cool idea. So to put it short and nice and succinctly, DevOps is the practice of the operations and development engineers participating together, working hand in hand throughout the entire application service lifecycle. So let's break this into the key components. The first 2, which you'll hear us repeat a lot through this workshop, collaboration and automation. These are the 2 most essential components of DevOps, which is, encourage collaboration across all stakeholders, and automate, eliminate time waste and optimize workflows that are, repetitive, that, companies find themselves doing a lot. And below are these like list of continuous integration, testing, delivery, and monitoring. These are all what make up like the infrastructure of DevOps. So continuous integration, when developers make changes to code, they want to be integrating it to the main source code frequently. And this is followed by, you might be worrying, what about, testing and protecting it? When it's integrated to the code, we want to encourage automated testing that will catch errors in the code very early in the pipeline. So, you integrate, you update the code frequently, and then you test it right away. On every single update, you do a series of automated tests, and you check if there's any issues. And if there are any issues, you stop and send it back. Say, there's a problem with this launch, and the developers can very quickly fix it and, try again. Once it's been tested and vetted, it's then passed on to the delivery. And here, these code changes are built, tested, and then prepped for production. And at this point, they are handed off to operations, and they are actually deployed. After this, it's continuous monitoring. Always be listening for failures, always be collecting feedback, and then if any bugs are detected, you remedy those bugs in real time. And you do that through using these previous tools, which is continuous integration, testing, delivery. Any changes that are any issues with the code can very quickly be monitored, noticed and remedied. Now, with this kind of technical aspects broken down, I'm going to go ahead and pass it to Vyas, and he's going to tell you guys about DevOps in the workforce.
As you know, DevOps is a growing field, and there's a lot more jobs nowadays that want a DevOps engineer in the team. So a DevOps engineer, they get paid from 72K to 146K, and the average base is around 99K. So some of the skills they're looking for mostly is cloud, such as using AWS, Azure, and GCP. Cloud is a huge skill that you need to become a DevOps engineer, because most of the companies, if you want to work for as a DevOps engineer, may require cloud. So mostly their servers and are in the cloud. The next one is Docker. Docker is a containerization tool to package code, and pretty much in the development cycle, when it helps the developer develop the code in the Docker uh, configure environment rather than environment. So when you pass the uh, code to the operation team, so that same environment is still there rather than the environment you work on your local machine. Next one is main thing is automation. So automation is a key part of to become a DevOps engineer. So you have to know basic CI/CD pipelines and different tools such as Ansible. Ansible, that's an automation tool to help you configure a service. Some of the responsibilities to become a DevOps engineer is to help analyze the current technology utilized within the company. So even though there are many companies, they have different practices using and different technology they use. So you have to know, based on the company you work at, what technology and practices they have implemented. The next is working along the project management team. So they have different requirements and different projects, how they want it. So it's important to know what the term and the terms of the project. Make sure everything is set to right. The next thing is about mentor and training engineers. Even though every day there's new technologies coming up about in DevOps, so it's better to help the employees to learn about these different technologies, how they can help implement new ways and better ways inside the project itself. And next thing is provide a clear goals for all areas of the project. So you have to provide better in the development side or the operation side. You have to help provide a clear goal, understanding the technologies and how it's incorporated with the operation team. Next thing we're going to talk about is some of the tools in the development cycle that are being used. So there are a couple of different processes. So in the plan stage, we use such as Git or GitHub. That's most of the where you store the code. I think most of y'all have heard of it. Planning also requires like making diagrams. A good thing you can use like Lucid Chart for diagrams and having collaborations such as using Microsoft Teams is one of the how you plan collaborate. Then you have build. Building is where you package up your project so that is ready to send to the deployment server. So in build stage, you have pretty much you have npm is a packaging, so you can use npm, you can use Docker to package your application. You have Maven to build your project. Then we have continuous integration, so CICD. That's where everything comes into play. That's where the build stage is talking to the deployment stage. So the tools we use are such as Jenkins, CircleCI, and Travis CI, or GitHub Actions. That's one of these popular tools that help integrate the development and the operation teams together. Then we have deployment tools. So deployment tools are like where you can configure some stuff in the server. We can use like a tool called Chef, Puppet, or Ansible to configure the environment you need easily, automated. And where you can deploy these stuff can be in GCP, Azure, or AWS. They have virtual machines where you can deploy your application really fast. Then after that, after deployment, you had to have feedback. So you had to know how your app is doing. So you had to monitor. Some of the stuff tools are Cynic. Cynic is pretty much a security tool that monitors your project, make sure there's no bugs. Then you have Splunk. Splunk takes your logs from your app and use the feedback to the development. If there's any error or any bugs, they automatically give to the development team. And Datadog is also the same thing. So this also creates a continuous feedback where the development team, if there's any bug or anything, they can easily catch and fix it and easily deploy the app itself. Next, we're going to look at the demo.
Oh, hey, really quick. Before we hop into the demo, we had an awesome question in the chat. Mohammed asked, "What does CICD mean?" So I'll go ahead and answer the question, and Vyas, I'd love to hear your answer to the question as well. So CICD is an abbreviation for continuous integration, continuous delivery. So it basically describes those two components that I mentioned a few slides back with the key components, where continuous integration is the idea that developers should be constantly making basically development teams should always be implementing their small changes and checking their code to their version control. So basically always be updating the master source code with small changes as frequently as possible. And this is what's awesome about this is it feeds into continuous delivery. So this picks up where CI/CD ends, and continuous delivery handles basically testing the code, building and testing the code, and making sure it's legit. And at this point, the idea is that you have teams that very frequently make updates, and then you have a system that handles those updates, tests to see that those updates are legit, all automated, and then then the developers can get immediate feedback, like, is this a good update? And if it is, then through an automated process, it's passed through to the deployment stages where it's then delivered. So together you have the CI/CD platform where developers make quick changes. Those quick changes are validated and proven, all through automated processes, and then it's deployed. So if I were to analogize this to like a website, well, actually, I'm not going to go there. That's what you'll see in our demonstration. I don't know, Vyas, do you have anything you might want to add to that?
So Mohammed, for a big project, you can see how this can be affected. This can be taken action. So pretty much in smaller project, you won't really notice. Let's say you're working with at least like two to five people, you won't really know. If you're working with like different teams on the same project, continuous integration is a huge thing where every team just pretty much push changes continuously, and it pretty much also continuous delivery, so pretty much able to deliver the app really fast.
I see. Thanks.
Yeah, no, thank you for the question. And guys, please, I want to encourage everyone to, send questions in the chat. There will be a question segment. We'll be taking questions at the end of the event, but if you have anything that comes to mind, feel free to drop a message in the chat, and we'll answer. I'll push it through to Vyas.
Okay, let's take a look at a demo. So in this project, we have built is pretty much a pipeline. So pretty much me and Nicholas are the developers here, and we're gonna commit the code to GitHub or Git, any version control system. So this is where Jenkins is going to listen to any changes or any like such as a push or pull request, and it's going to build the app based on that request, and it's going to test it and make sure and build an app package. It's going to package that app and it's going to send that to our server that's in DigitalOcean. So before even this pipeline is going to be happen, so what we usually do is we're going to have a developer usually with their root account in here. They can do commands such as build this app into a package, able to deploy it on their site. So this is like manual work. This is it takes up so much time of their own what they can encode, and they cannot really get a continuous feedback. So this pipeline helps the developers or the team usually save so much time. So let's start look at the code. So this is our GitHub. So this is a basic React project we have here. So we have it deployed already on here. So it's a basic React project.
Yes, sorry to interrupt you, but I don't think so. We see the code.
Sorry, I can't hear.
Oh, we can't see the code really. You're showing us code.
Yeah, you see it stuck on the last slide.
Oh, okay.
Oh, thanks for pointing that out. I thought he was just explaining.
Let me try reshare.
You're in the screen.
Yeah,
the
if you
PowerPoint. That's probably why.
if you go back to where it says to share your screen, it should like have like a little down arrow, and then you can switch it to like your screen instead of the application. It's like a screens.
Can you see now?
Yes, perfect.
Okay, great. So this is our GitHub. It's on GitHub. You guys can go. It's open source. So we have a basic React project that is deployed to this website, and we're gonna change a lot of stuff. So what we're gonna do is we have Jenkins in here. So when someone changes, let's say Nykolas makes a pull request, right? So we can see any pull request. So Nykolas, you can make a pull request?
Yeah, for sure. Let me go ahead and do that. So I'll go ahead and make a pull request to your... Sorry, give me one moment. It's like hidden from me. Here we are. Okay, I am making the pull request.
Awesome.
So
Before
yeah, oh, sorry. Here I've made some very important changes. It's going to improve the performance of the website by 50%.
Nice.
Yeah.
So before we look into pull requests, let's talk about Jenkins. So Jenkins is a CI/CD tool. So basically, we can make a pipeline. So this is one of the pipelines we have here, test. So what test does is we have to configure it. So this if you go to configure, and you see how we connect this Jenkins to our GitHub. So pretty much we provide our GitHub URL. So you can provide a credential if you have a private repo. And we're gonna look inside the branch main. So you guys must have heard the GitHub change the stuff from. Can you guys not see or?
Oh yeah, I can see. What did they change?
Okay. I was just looking at the chat. They were saying. Yeah.
Oh. Right. Okay. So yeah, it seems someone's having trouble viewing the screen. Okay. Yeah. Sometimes Discord has a problem with the stream like that. Yeah. Rejoining and hopping back in normally fixes it. Alright, cool. I think you're good to go.
Yeah. Awesome. So pretty much, as you know, GitHub changed their branch name to main now rather than the master.
Oh no, that actually happened. I thought that was.
Yeah.
I heard about like like people were talking like master's a little outdated of a term, and oh, I didn't know they actually
Mhm.
changed it. That's funny.
Yeah, now when you have it on local, it's automatically master, but make sure you change it to main. Yeah. So there's something called polling. So what it does is Jenkins, our server right here, listen to a webhook. We configure it in GitHub. So inside the webhook, we configure to listen to our Jenkins server. And before that, I'll show you where we deployed our Jenkins server. Our Jenkins server is deployed on DigitalOcean, so right here, and we can see our um, production server that's been deployed. So pretty much, you guys can get DigitalOcean for like $50 because all of your college students, and there's something called GitHub Student Pack, and you guys get free $50 credit. And y'all can try this after the presentation itself. So let's get back to this. So we're gonna set up a build command. So this is we planned our project. So also in GitHub we have a project tab where we can organize and start Trello board. So I will show you a better view of this inside the next demo one. So this pretty much we planned it. We have a source code. Now we need to build our app packages. So now we're gonna have build it. So Yarn is a package, like it's gonna install the dependencies for our React project right here. Under the package.json, we have some dependencies we need to install. Then we need to build our app. So this is gonna build our app and create a build folder for us. Then we need to test and make sure everything works and make sure our code is running fine. And so this test is determined. So if the test doesn't pass, pretty much this pipeline fails. The next step is trying to send the build folder after everything passes to the, and so pretty much we're running our project in Nginx server. That's where we're going to display our app itself. So what we do is we configure SSH. So we're using SSH to send over our files to the production server. So we specify what folder you want to send over. We said we want to send over the build folder, and what repository, what folder you want the code to be in, the build folder. So I'm going to put it inside the prod folder. This is all the configuration, basic configuration you need for this pipeline to work. So now let's take a look at,
Hey,
before that, we have,
I had a really quick question. So can you go back to that configure page?
yeah.
So all these actions that you're doing, let's say let's say I was doing this manually. How would it be different? Like, are these the same commands that I would be running like in the build environment? I guess the build stages. Would that be
Yeah,
the same thing that I'd be doing like if I were to do this manually?
yes. So if you're doing manually, this is the same thing. So whatever you're doing manually, so you're doing pretty much putting inside a command inside Jenkins. So this is pretty much automating your workflow. So rather than you waiting for everything to pass and everything, this pretty much Jenkins will automate everything for you and make your development cycle so much faster.
Right, right. So you had like that build where you built the app and then you ran some tests on it, and it's only going to go to the next stage if like the one
Hmm.
before it passes, right? Like if it
Yes, that's
doesn't
right.
crash or
Hmm.
anything.
Yes.
Got you.
Yeah. So as you can see my build history have pretty much, so the blue means everything is good, successful. Yellow means kind of unstable. Red means failed. Sorry, I have one failed, but what's my test? Probably. So if it's blue, everything's good. So I had a couple now. So I have 23 of them. So now let's take a look at Nykolas's pull request. So I go back to GitHub, click on pull request, and you see Nykolas has a very important change he has.
Hmm.
And let's see what the files he has changed.
Oh, and by the way, guys,
Yeah.
I just want to say, if you're making a pull request or like commits, please have descriptive messages in there. This is just, oh, you don't need to look at the changes too much. You can just go ahead and send it through.
Okay. I'll review for changes. I'll just leave a comment. Looks Like, so it looks great, and I approved his request, submitted. So if I go back, and everything looks good, now I can just merge the pull request. I confirm the pull request. Now let's go back to Jenkins. Now Jenkins is going to get triggered because I just pushed a changes to my main branch. So it's starting to build. Yes, it's very, very important change.
And you can see like the commands getting run, like when you had those commands set up to build and test it. Like that's what's going on right here, right?
Yeah.
Yeah, this is some seriously cutting edge stuff right here.
Yes. So as you see, yarn, this is the command we defined. So it's going to install the dependencies. Now we have yarn build that's going to build our app and make it into optimize it for production build. After that, we're going to test our app. So yarn test. So it looks like everything worked great on when it pushed the main from Nykolas's changes. And in here, we transfer our file to our production server. So everything is successful, as you see. Let's go back to the project. Everything's great. Now let's take a look at the changes. So our current website looks like this. Let's refresh now. And wow, what is this? It's a potato. Mohammed, this is for you.
Yeah, Mohammed, this is for you. Where's Mohammed in the chat? This one's for you. This one's for you, man. No problem.
We have some changes. Nykolas is #1 React developer.
Yeah, only the truth.
Yes. So as you see, so pretty much our Nginx server is deployed here on our DigitalOcean. So everything is getting pushed here, and I rented a what's called a domain for free from using the GitHub student pack. Y'all can use this to get a free domain name for 1 year, I think. So it's very cool, and y'all can host your own website also from that.
Right on. So what just happened in that demo is, so you basically just accepted, like you just updated your code base, and within, what was that, like a minute or two? Like
yes,
all the changes that were, all the new updates to the to the code have been reflected on the deployment version. That is like some really cool stuff. And guys, like this is some this is like a seriously powerful tool, because like if you're working on a bigger project where you're constantly updating the code, like within seconds you already have it, live and on the website. And I'm not sure if any of you guys have tried to host your own website before, or I don't know, like public, like tried to deploy a project, but it's not like a very convenient process to go through and like actually build it and then actually like deploy it. Like there's a lot of steps involved, so it kind of discourages developers from updating frequently. And with this like within seconds, my changes were already incorporated, built, and then now it's live like within a minute. That is really cool stuff, really cool process.
Awesome. Now I can just pull the changes from the current branch. So git pull, I have done right here. So I pull my changes. I have everything right here. If I want to change and push to the main branch itself, let's change Nykolas to Vyas.
No.
Okay. So in here, you can see VS Code has picked up my changes. Thing is slow. Yeah. So let's add.
Yes, you probably need to reshare your screen again. It's stuck on the.
Oh, okay, I see.
Oh, is he? Oh, yeah. Oh, and we have an awesome question in the chat. If UH has the DevOps courses, not to my knowledge. I'm looking it up right now. I'm not sure if you heard of anything like that.
So I haven't I heard no DevOps courses, but I know like if you take SE with Singh, he requires you to have like a testing and a code coverage. So you kind of apply like a CICD also in there. So it's really useful, and that's the closest thing I know to like a kind of like a DevOps at UH they offer.
Could you repeat what class that was?
Software engineering with Sing.
Engineering with Sing. Cool. Oh, and by the way, when you share your screen, like when you're changing it, like if you go to
Yeah.
that screen, it'll have like on the top of like the panel that pops up, it'll have like screens and then applications. And then if you switch it
Yeah.
to the screens, you can do like your entire window instead of like an individual app.
That I did, so I wasn't sure.
Okay, right on.
Yeah. There we go. So I'm gonna push the changes. Commit my changes. And push it. So I pushed my changes. Now let's go look at what's going on in Jenkins server. So let's go to Jenkins. As you see, it's going to take like a few seconds. Now, see, Jenkins got a notification or like got notified that, oh, there was a change in my GitHub. Now, let's go here. It's going to run the same everything, test, build, install the package, send it to the server itself. So it doesn't take that long at all. So this is all automated, and you can do whatever you need to do at that time. Usually, bigger project takes a longer time to bundle up everything and test everything. So rather than you waiting it, you can have the CI do it.
Yeah, right on. And guys, and don't feel limited to what we're showing you just here today, because right here, this is a very simple pipeline that we have. We're only building and testing. But companies like larger companies can introduce a variety of tests. Like, let's say they want to do different integration tests. They write their own integration test scripts where they have a handful of different stages. It's also common to see maybe like a manual approval. Like, let's say someone integrated their code and it got through all the stages, and at the very end before it actually deploys, there's like a manual approval check. And what it'll do is it'll wait and like query whoever is responsible and say like, this is ready to go, it's been tested and vetted, like, do you want to approve? You click, and like right here what we're showing you is a pretty simple example, but like it can get pretty complicated, and you can add a lot of complexity to this, which is what's so beautiful about it, is it's like extensible.
So let's refresh this page. Let's see, our change has been made.
It's a fake change. I don't agree.
Okay. Now another example, what we do in CougarCS. So we have a web dev community. That's where we have student members who help us build the website. You guys can join also. You can talk to Shub. He's our webmaster for CougarCS. So our website, we have our CougarCS client. It's running React, and what we do is our plan is we have a project tab here. That's where we have our task that needs to be done, completed. We manage different tasks using this like a Kanban. It's called Kanban board. So you can drag, drop, and you can see what tasks are done right here, what tasks are in process, what needs to be done. So you see all these coming up stuff in what's going on with our web dev team. You guys can follow also along, and you guys can fork this to make requests. So I was going to show you, this is a thing called GitHub Actions. So it's a CI/CD pipeline thing for GitHub. I think it's free for up to some minutes per month, but I have not passed it but it's really helpful. So as you see, there are different builds we did in here. And let's take how we defined our steps in here. So GitHub requires a folder called workflow under here. And in GitHub, we have to define our steps and everything inside that YAML file. So let's say, for example, you can see how you can read this. YAML is kind of confusing first, but it's pretty much like a plain, it's really it's easy to pick up. So say on pull request or push on push on master branch, run this job. So pretty much it's going to run this job on our server, on Ubuntu server that GitHub provides. So GitHub have these actions they provide us. So pretty much it's like a pre-made code what this one does is check out our code and put it on our server. And this one set up our Node.js environment in that server using whatever Node version you want. Then we install the packages or the dependencies inside from the package.json, and we build the app. So pretty much this is our build step. So we just make sure everything works. If I go back to deploy, the only thing that changes is on the branches. So if it's in the prod branch, we run the same steps, but we provide environment keys. So pretty much our secrets and deployment. This is our last stage. This is where we going to use the action to send our files to the FTP server where we host our code. So this is a simple workflow for CICD. Now this can get complicated. You guys can add Docker, different tools to make it more automated also. But this is a really simple pipeline you can follow.
All right, cool. So I guess let's take a pause here and open the room up to some questions. Does anyone have any questions like on that demonstration that they might be wondering? And we're happy to answer like on any. Oh yeah. Actually, I guess before that, let's hold your questions for like just one more moment. So here we're getting towards the end of today's event. We want to share some useful resources and links. If you guys are interested in doing some more reading and seeing how, if you're like interested by the concepts we introduced today here and like kind of want to take it further, we included some great links here for you guys to pursue that. But yeah, and don't worry, this PowerPoint, I'm actually going to provide the PDF right now. Let me put it in the chat. So you guys can just download this and click on these links at your own leisure. And yeah, so now we're open to questions. So please ask away if there's anything that is intriguing you guys.
Y'all can unmute if you want also.
Yeah, you guys can all unmute, by the way. And don't be shy. This is a learning environment, so please ask away. And if you don't want to use your mic, feel free to send a message in the event chat. So, cool. So we have a great question from Mohammed. He asked, is the CougarCS website deployed on AWS or Amazon Web Services?
It's not. We have our own private server. So AWS pretty much just three different stuff. There's private, public, and hybrid cloud for AWS, but we don't use AWS. We have our own server that has been deployed.
Cool. Yeah, great question. Thank you for asking, Mohammed. And yeah, AWS. Well, AWS is what is cool about it is it offers like all these services, like basically prepackaged solutions all built together in it basically creates this like ecosystem where you can do this all very easily. What we showed you here today is more manual. Like Vyas has a lot of technical skill, which allows them to set up the Jenkins and the Git, the webhooks and DigitalOcean and stuff. But if you were doing this on AWS, they have like everything integrated, like all in one. Like for example, they have their own code commit, which is similar to GitHub. Then they have their own code pipeline and build stages. So it's basically they bring it all together in one. And yeah, AWS is also the largest cloud provider. So if any of you guys are interested in like picking up that skill, it's very, very hot. So we have oh, sorry, go ahead.
Usually, bigger organizations may have private cloud, and like medium-sized organization may use AWS's resources to host their stuff, like bring up different servers. So many big companies have many like hundreds of servers they manage. So one way they do it automatically, they can use automation tools such as Ansible or Terraform is one of other great tools. That's where you can automatically deploy any server. And these are good tools, good to learn. This is really helpful, like a good skills for you guys.
Absolutely. We have another great question from Liam. He asked, why wouldn't an organization adopt DevOps? So why wouldn't an organization adopt DevOps? So yeah, that's a great question. So I think like one of the main challenges to adopting DevOps is like it requires a lot of technical expertise. Like it requires a lot of domain knowledge on like DevOps practices, and you need skilled workers. Like someone like Vyas who knows how to set up these automated workflows. It's not necessarily an easy endeavor to do correctly and do properly. And this is where a lot of like great cloud providers come in. Like Azure or Google Cloud Services, Google Cloud Provider, or AWS, is because they offer these like solutions where companies can do it. But even when you're using like AWS infrastructure, you still need technical staff with the skill to be able to do this. And this is part of the reason why DevOps is such an attractive skill set right now, is because what we have is a high demand. Like DevOps is like it's proven that DevOps gives companies a serious competitive advantage over those who aren't DevOps enabled. It's just that it requires technical expertise, and right now the market is short supplied, and that's what makes DevOps so attractive.